This is a further attempt to assist any listeners in their contemplation and understanding of the nature of language. I am adding these further episodes because of recent comments regarding argument in popular culture over words called social constructs, especially involving linguists, psychiatrists, and psychologists, and the computer engineers with whom they work, calling themselves cognitive scientists, as a means to give the impression that they are getting around the problems of philosophy of language and the metaphysical and ontological problems we have contemplated in earlier episodes regarding the meaning of words and word games. It is important not to get fooled by the omnipresent fad in our modern technological society of word games in which unscientific techniques call themselves science in order to get undeserved credibility for what they are doing, or call something a social construct is a technique to arbitrarily and randomly change meanings simply for aesthetic reasons, or more likely simply to create pragmatically meaningless words that are meaningless except for pragmatically giving the speaker of the words or the word game users more power by the use of those words and serving no other purpose other than power as an end in itself. Remember what Wittgenstein said about word games and philosophy. The limits of my language means the limits of my world. Philosophy is a battle against the bewitchment of our intelligence by means of language. In this episode, I want to introduce you to Wittgenstein's rule-following paradox, or RFP for short, as it's known. It's contained in his second and last book, Philosophical Investigations, at paragraph 201A and a little bit before and after. I want to introduce you to it as a further clarification of how language is used and abused. The paradox, as he states it, is fairly short and straightforward. Quotation, "This was our paradox, no course of action could be determined by a rule because any course of action can be made out to accord with the rule," close quotation mark. A good, simple, and straightforward exemplification of this paradox at work can actually be seen in what is usually a very complex area of rational thought, physics. Go back to the story of Isaac Newton dropping an apple or having an apple fall on his head and then making measurements of the motion of the apple over time. He inductively reasoned from his measurements that the instantaneous velocity of a fallen object at any given time is V equals gt. From a finite amount of observations, he induced this rule for deductive use in an infinite amount of future or past possibilities to deduce instantaneous velocity. If you have listened to my prior podcast on the induction problem and the problem of cause and effect, you should infer a problem with this reasoning already. There are an infinite number of theoretical mathematical functions that could satisfy the finite set of observations taken. V equals gt is simply the simplest one, and thus is accepted as science through the application of Occam's razor, as discussed in prior podcasts on the philosophy of science. Also, no matter how many observations are taken to test a rule, they will always be finite. There's no way to do the infinite number of observations that would be required to test the infinite applicability through deduction of the rule, or even to logically deduce this rule. For example, as far as we know, the observations could be limited to events on Earth or only involving apples. Until we experiment with oranges or with apples on another planet, Newton and any followers of this rule had no way of knowing, and we have no way of knowing, whether the rule is the necessary deductive rule they took it to be. So, what does it mean to follow this rule of V equals gt? Instead of one of the other infinite possibilities of mathematical functions that could solve and incorporate the finite observations, this simplest version is accepted as the rule to follow. Why? Is this simplest of possible rules, version V equal gt, a thing in itself that exists separately from the observations taken, so that when discovered it allows us infinite deductive application? Is the rule of a given rule-following situation a thing in itself, separate from the observations and the usefulness of that rule to those observations? Given all rules will develop from a finite amount of observations, there are always an infinite number of possibilities that can explain any action as either following or not following a given rule. Until these infinite events actually happen, what is it we are following? This is the RFP. It turns out that V equals GT is not such a thing in itself, because Einstein later showed this rule was not in fact, he showed this rule was in fact wrong as you get to larger space-time applications and geometries, and thus needed to be amended to a different rule to be predictive. I believe it was changed to V equals G L over C or something like that. Eventually, in relativity physics, the entire concept of gravity as a force acting at a distance was eliminated in theory to be replaced with space-time relativity calculations. So are these new rules developed by Einstein in relativity physics, since these are also based on finite observations, are they a thing in itself? Are they something that exists separately from the observations, from the acts of complying with them? How do we know the same paradox is not true of all rule following words or word games, or languages, word game languages in which we assume or pretend there exists a rule that we follow that is separate from the act of following, or that is separate from whatever observable results occur from that act? The reality is we do not. In any rule-following situation, there is no reason to assume that the rule being followed exists independently of the act of following or of the results achieved. This is true of even the simplest of rules. For example, the rule, quotation, "Every driver of a vehicle approaching a stop sign or flashing red signal shall stop," close quotation. Seems simple and straightforward enough, yet every day the traffic courts of the country are filled with people arguing with police officers as to whether they stopped or not at a stop sign. What is it that stops at the sign? Bumper, front wheel, steering wheel, front seat, you. How far before or after the sign do you need to stop, especially if you need to see traffic? What if stopping at the sign does not allow you to see around the corner, nor others to see you? What do you do at that point? What if there's a pedestrian crosswalk? What if the stop line on the street's missing? Where do you stop? Stop for how long? Is half a second enough? A second? 2 seconds? If you follow this rule, so you think 1,000 times until one day a police officer stops you because you were not stopping long enough, according to the police officer. You did a rolling stop, as they call it, or you stopped too far behind the stop sign or too far in front of it. The officer considered your interpretation of the rule incorrect. So it turns out you are not following the rule for those 1,000 times. Where do you stop now under the new rule given to you by the officer, and how long do you stop? Answer, you stop where you have to stop to avoid getting the ticket. The rule does not exist separately from the observable events involved in following the rule. Rule following does not exist separately from the observable events involved in following the rule. No matter the simplicity or the complexity of the rule, there are always an infinite number of possibilities that were never observed in creating the rule, and in following it that could be used to explain either compliance or non-compliance with the rule in your acts. As Wittgenstein stated, given the undisputed fact that you are taking a finite set of observations to create a deductive rule to apply to an infinite number of possibilities, rule following cannot be a deterministic, deductive following of a rule existing as a thing in itself, because no course of action could be determined by a rule, because any course of action can be made out to accord with the rule. This paradox even applies to mathematics. I've put an example of the paradox applied to the simple word game of addition on the web page. This is an example developed by the philosopher Saul Kripke. I put it on our Sam Pebbles web page in the Philosophy of Language section page. Thus, even with rule following, the meaning of the rule following is the same as the previously contemplated pragmatic meaning of non-existential words and word games, and in fact is just another non-existential pragmatic word game. It is a difference in degree and not of substance or essence. the meaning of rule following is the usefulness of the rule following. An assertion that a rule is being followed is the same as saying that the observable actions or results of the language word game of the rule meets the intentions or expectations of the language word game users. It is important to apply this philosophy of language to modern attempts to bewitch our intelligence by means of language, as I will discuss in the next couple of episodes.